So what I explained, what I taught in the previous time was a way of finding a prediction of a game with the smallest assumption, right? When we are trying to find a strictly dominated strategy, I don't care whether my opponent is crazy or mad, right? Even though my opponent player is mad or not rational, I don't care because I'm going to choose the best one for me. I always can find the better one, better strategy for me. Okay. So going back to the Prisoner's Dilemma's game. Prisoner's Dilemma's game, if we play this game, we can predict at the end of the game, players will choose compass and compass, right? And these are outcomes: 10 years in prison, 10 years in prison, right? But beside the game theory, this Prisoner's Dilemma's game is very important because it tells us very interesting topics. Maybe if you know a guy, Adam Smith, who is a founder of economics, then he said like this: okay, if people are selfish and rational, then no matter what they are choosing, at the end of the day, their chosen activity will increase a society's well-being. That's what Adam Smith said, right? Okay, what Adam Smith is a founder of economics, and he argued like this: okay, if people are selfish and rational, and they caring about themselves, they don't care about the society. If they just look for the best option, best strategy for themselves, at the end of the day, society's well-being will be increased or improved or to be optimal. That's what Adam Smith said. But look at this. Here, in this example, in this society, there are two persons, player one and player two, husband and wife. Just there are two persons. This is a very small society with two persons, right? They are choosing the best option for themselves. Husband chooses compass because that's the best option for the husband himself. And wife will choose compass because the compassion is the best option for the wife, right? Herself. And as what Adam Smith said, in this case, in this small society, this outcome should be the optimal for the society if we follow what Adam Smith said. Are you following? But look at this. In this small society, the summation of the payoff of these two players, because there are only two persons in this society, summation is minus 20, right? This is minus 26. If we sum up, minus 26, minus 6. So in one sense, minus 6 is the optimum for a society, for this society, right? However, here, if we follow what Adam Smith said, he said, if players are choosing an action with, if a selfish action, and if they have enough rationality, then no matter what they are choosing, it's for them, but at the same time, it's good for the society. However, it's not. In this society, best option is to both choose to deny, but they didn't choose. They just choose to compassion, right? It's not the optimum for this society. So this is a kind of a counter example of what Adam Smith said, right? And again, why this is happening? Because here is an interaction between these two players. When Adam Smith said this kind of argument, actually there is no interaction between players. However, here, no matter what you do as a seller, no matter what you do, how much you choose, how many goods are you selling, it doesn't matter. It cannot influence the market. Regarding what Adam Smith said. But here, if you choose this with this, it will change other players' payoff. So they are interrelated. So situations are different. Okay? So that's very important example of that. Returning to the game theory itself. Okay. Previously, when I explained a strictly dominated strategy, if this person is rational, again, no matter what you are doing, my opponent what you are doing, whether you are rational or mad or irrational, it doesn't matter. I'm not going to choose strictly dominated strategy, right? Now, let's find my strategy or my behavior in a different sense. Previously, I don't care about my opponent's strategy. However, sometimes when you try to find a strategy, a natural way of it is to expect what my opponent will do, right? Say differently. When we are playing a game, rock, paper, scissors, what it means, if I'm taking a strictly dominated strategy, what it means, I just focus on myself and try to find which strategy is unnecessary for me, right? However, a natural way of winning a rock, paper, scissors game is that usually we try to take an expectation or belief about what you are doing, right? We usually try to have a belief about what you are doing. That's a little different approach. So take this approach. A player can guess the belief of other players' strategy. I think that is a more natural way, right? Then we can define a term called the best response. Best response is like that. Okay, in a rock, paper, scissors game, well, if I believe that you will give me rock, probably the best response for me is to paper, right? If I believe you are playing rock, then my best response about my belief will be paper, right? If I believe you are going to play scissors, then my best option will be playing rock. What we can see here is that it's like our behavior will be relying on my belief about what you are playing. This is totally different approach from a strictly dominated strategy. When I was talking about a strictly dominated strategy, I don't care about what you are doing, right? Even though you are rational, irrational, mad, I don't care. But if I'm taking this way, what I'm going to do is that, okay, well, I need to know what maybe I need my belief about what you're doing. Based on that belief, I'm going to choose my best action. That is called best response. So suppose a player I has a belief about other players. Okay, I'm going to explain this term just a little later about other players' strategy. Based on that belief, I can find the best response. This strategy gives me the highest payoff for me. Okay, say differently. Best response function is like, if I'm having a belief about other players' strategy, then I can find the best strategy. Before going further, I'm going to introduce this term. Say like this. There are two players. 1, 2. Then, usually, this is the first player's strategy set. Okay? Sometimes I can use this term, -1. It means, other than me, all the players' strategy set. When there are just two players, it means second player's strategy set. when there are 3 players, this is refers to the first player's strategy set, right? And also we can say like this. It means strategy set older than me, older my strategy set. So it will be 2 and 3. Take a Cartesian product. So if I'm giving like this, okay, S1 is left or right, S2 is high and low, and S3 is A and B. Then this is S1. S minus 1 is this. High, low times A and B. Okay? What other players will do? That's S minus I. But because I'm putting here delta, it means I'm also considering a mixed strategy about this. Okay? Regarding terms, I'm going to explain more and more again and again later. But anyway, so a best response is that when I'm having a belief about what other players are doing, based on that, if SI gives the highest payer to me, then this SI is called the best response, based on my belief about other players' strategy. Okay? I'm giving you an example that probably it will be better for you. So this normal form game is the same as before. Okay? For UMD, it's like that. So let's say that I have a belief. I'm a first player. So I have a belief about what second player will do. Okay? I'm representing this way, like, okay, the first number is representing the probability of playing L for the second player, and the second number, 2/3, is the probability of playing R as a second player. So I believe that second player will mix L and R. Say it differently. I'm giving you an example like this. Okay. Let's find the first player's best response. If I believe second player is playing L, then my best response is to play U. Because I believe you are playing L, for me, it's better to play U because I believe you are playing L. Or if we are playing all, if I believe you are playing all, then for me, okay, M is better, or the best. Right? What if I believe that you are playing this? Here, instead of writing in this way, I'm just writing it this way. These are the same thing. So anyway, if I believe that you are playing L with 1/3 probability and R with 2/3 probability, I also can believe like that. Because, look at this. This strategy, this belief already include mixed strategy about other players. Then, because I believe you are mixing NLR with this probability, I can make expected payoff about the players. So if I believe you are mixing 1/3 and 2/3, then 4 times 1/3, 0, so that 4/3. Right? Look at this. Because I believe that you are playing 1/3 L, 2/3 R, so that if I'm playing L, probably you will get 0 times 1/3 And four times 2/3. So that 8/3. I'm expecting this pair, right? Say differently. Probably 0 will be happening with 1/3 probability, and 4 will be happening with 2/3 probability. That's what I'm expecting. And for the second player, still I don't care about the second player because I'm the player 1. But anyway, I can calculate it. 0 times 1/3, 0 times 2/3, so that's 0. I'm expecting 0. Make sense? Anyway, so like this, we can fill in these numbers like that. Then, if I believe you are playing, second player is playing like this, I'm going to choose M. Right? Because I'm a rational person. If I believe, I mean, it doesn't matter why I believe in that way. Why I have those kind of belief doesn't matter. If I have this belief, based on that belief, I'm going to choose M because M is the best response for me. Okay? Then, based on this idea, we may say like this. We may find some strategy that cannot be a best response with any kind of belief sometimes. You know what I'm saying? Say differently. The best response means that, okay, if I have those kind of belief, I'm going to choose this strategy. Because for this belief, the best response gives me the best payout. Right? However, sometimes I may find some strategy which cannot be best response, even though there is any kind of belief. I cannot find any belief which makes this strategy to be the best response. Sometimes. You know what I'm saying? Then sometimes we call this a never best response. Again, I cannot find any reasonable belief that makes my strategy to be the best response. That's never best response. Right? Right? So then think of in this way. Okay, when I try to play a rock, paper, scissors game, well, if you are playing, if I'm expecting you, if I believe that you are going to play rock, with that belief, I'm going to play paper. That's the best response. If we are playing scissors, if I'm expecting that, then I'm going to play rock. That makes sense, right? Also, if we are playing paper, probably I'm going to play scissors. Okay? So sometimes each strategy can be played with some kind of belief in this example. However, before doing this, I'm going to show you this first. Look at this. This is another normal form game. There are two players. First player's strategy set WXYZ. Second player's strategy set LR, and these are pair. And implicitly, we assume that these players are playing this strategy simultaneously. Okay? Then this is a normal form game, I declare. Then, look at this. Well, maybe, look at this. If I believe that second player is playing L, then probably I'm going to play Y. Right? I don't care why I'm having this kind of belief, doesn't matter. If I have those kind of belief, then I'm going to play the best response, okay? If I believe you are playing R, then I'm going to play X, right? How about this? Is there any way maybe I may have a reason to play W? I think not, right? When I try to play W, well, maybe some cases for 2 is fine, but it's better to play Y. No matter what you have, right? No matter what kind of belief I have, probably I'm not going to choose W because I can find a better strategy, right? Right? So, in some sense, this W can be never best response, or it can be best response in any beliefs, or called never best response. If I'm a rational person, and if I have a rational belief, probably I'm not going to choose a never best response, right? If you are a rational person and also you have a rational belief, probably you won't choose a never best response because there is no belief rationalizing your choice, right? Right? Those are a little different between a strictly dominated strategy and a never best response, right? Strictly dominated strategy, what I need is just my rationality to find a strictly dominated strategy, right? But for the never best response, what I need is rationality and at least rational belief. Kind of. I need a right belief, not right, but at least my belief should be rational, can be rationalized. If I have a very weird belief, then I may choose something wrong. But at least if I have rational belief, then probably I won't choose never best response because there is no belief that can rationalize my never best response strategy. It makes sense? Again, when I'm talking to best response, I need my belief or player's belief. But sometimes there are some strategy that cannot be best response, even though what kind of belief I have, it doesn't matter. I cannot make this strategy to be best response. Then I'm not going to choose, right? In this case, I'm also considering my belief. Here, belief about other players doing. But here, I don't care. I'm just caring about myself, whether I'm rational or not. A little tiny different approach, right? However, in a finite two-player game, strategy state is finite, and also players' number is just 2. Then, strictly dominated strategy is exactly the same as never best response strategy. Say differently, just forget about notation. So what this says, in a finite two-players game, when there are just 2 players, strictly dominated strategy is exactly same as never best response. What it means. If a strategy set, a strategy is strictly dominated, what it means, there is no belief that can rationalize this strategy to be best response. So that I won't choose that strategy. But for any finite game, a strictly dominated strategy are never best response. However, reverse is not true. There are some never best response strategy which is not strictly dominated strategy. Okay? So these two concepts are tiny different, tiny different. But think about it. I was explaining two different approaches how to find the best strategy for me. One option was that if I'm a rational person, I don't care about you. No matter what you are doing, I don't care. I'm not choosing strictly dominated strategy because I can find the better strategy for me all the time. That's the basic rationale of strictly dominated strategy. However, regarding never best response, okay, when I try to play a game, probably I'm going to have a belief about other players' strategy, right? Sometimes I can find a strategy which cannot be the best response, no matter what belief I have. I cannot rationalize it, right? Then I won't choose that. Probably you won't choose that. When I'm playing this game with another player, probably I believe that this player won't choose never best response because he or she cannot find any belief that can rationalize his or her strategy. Does it make sense? But this the concept in a two-player to finite two players game, these two concepts are the same. A strictly dominated strategy is a never best response, and never best response is a strictly dominated strategy. What it means, if I'm not choosing a strictly dominated strategy, or maybe I can find any rational belief that rationalize this strategy. However, any finite game, more bigger size game, then a strictly dominated strategy are never best response, but the reverse is not true always. I'm just introducing the basic concept why I'm choosing this or why I'm not choosing this. Okay? Before we are not doing Nash equilibrium today. However, this is a strictly dominated strategy. This is never best response. Also, we have a Nash equilibrium. Probably you may be familiar with this concept of Nash equilibrium. But what's the difference between those three? Nash equilibrium basically need players' rationality plus correct belief about other players' strategy. I'm going to explain this part again after teaching this Nash equilibrium again. However, Nash equilibrium basically need players' rationality along with their correct belief. Their belief should be correct. But never best response need rationality, players' rationality plus their rational belief. It doesn't need to be correct belief. However, they won't choose never best response because they cannot find the belief rationalize their never best response. Here, strictly dominated strategy, what they need is just players' rationality. They don't care about the belief anything. However, in the two finite set game, those two are the same. And also, in a more general sense of class of the game, in a finite game, then strictly dominated strategy is a never best response. So I'm just talking to you how we can rationalize these two concepts. I just introduced here a little, but I'm going to say again this part later after finishing this Nash equilibrium stuff. So going back to this slide. This part may be not easy for you right now, but maybe if you study again, probably you can find something interesting here. This is the basic concept. So again, if I'm going back to one slide, I can define BI set like this. BI set is the strategy set which can be rationalized by a belief. If there is any kind of belief that makes that strategy to be best response, then that strategy can be in this BI set. So if a strategy is a member of this BI set, it means we can find a belief which can maximize, which can rationalize that strategy to be a best response. Okay? Then, so never best response is exactly opposite of this set. And also we can define UD. UD is a kind of the set of strategy for player I that are not strictly dominated. So this is the opposite of strictly dominated strategy. Okay? So if a strategy is a member BI that we can, this can be best response for a certain types of belief, and strategy is a member UD, that it means this is not strictly dominated strategy. Okay? Just the naming. Then let's check. Let's find the B1. A strategy set which can be best response. If a strategy can be a best response, no matter what belief it is, then this can be a member of B1. Okay? And I said that in a two players finite set, those two are the same already. Right? In the previous slide, I argued that without proof, but these two sets are the same. So strictly a strategy which is not a strictly dominated and best response set are the same, finite two-player set. So this is a finite two-player set, so that those are the same. So when we try to find a set of best response strategy, then we can find it like this, as I did already. If I believe that the second player is choosing L, I'm going to play Y, so Y is a member of V1. Because I have a belief that if I believe that second player will play L, then Y is the best response for that. So that Y is a member of V1. Okay? And if I believe that if we are playing L, probably I'm going to play X. So that X is a member of V1. Even though I'm just used a new term, but it's just I'm just gathering. Strategy can be a best response for certain types of belief. Okay, so X and Y can be best response for a certain type of belief, and we know that W is strictly dominated by G. Because 5 is greater than 2, 3 is greater than 2. So that W is strictly dominated by G. I argued that without proof in the previous slide. Never best response is strictly dominated strategy in a finite two-player game. So that because this is strictly dominated, so that this is a never best response. So that I can eliminate this strategy. So W is not in B1. Are you following? Probably you need to review the recorded lecture if I'm uploading. Okay. Let's check the last one, Z. Whether to check whether this is a never best response or not, we should check whether this is a strictly dominated strategy. Because these are the same in a finite two-player game. So let's check G. If there is a strictly dominating strategy, then G it will be strictly dominated strategy. At the same time, that will be never best response. Okay? That's fine. Because we are not going to choose W, so we can care about W from the beginning. So what remained here is that X and Y. So if I'm mixing X and Y, as I did before, let's say that let P be the probability of choosing X. And I'm going to choose Y with 1 minus P. Because I'm not going to choose W in any sense from the beginning, because that is never best response. And strictly dominated strategy. So I'm going to mix those two. Then let's check this. P times X plus 1 minus P, Y. Then I'm going to expect 2P plus 1 minus P, 6. P times 2 plus 1 minus P, 6. Right? And 7P 1 minus P times 1. Right? If I'm mixing X and Y, then I'm going to expect this expected pair. Right? If this is greater than 5, at the same time this is greater than 3, if I can find an interval of P which is satisfying those two inequality, it implies that this will be strictly dominated by the mixed strategy X and Y. Right? So let's find there is. If I'm doing this, 2P, 6P minus 6 equals AP minus 6 greater than 5, then something wrong. This is wrong. 6 minus 6P. So 6 minus 4P greater than 5. Should be greater than 5. Okay, just the algebra. So P is less than 1/4 here in this inequality. And here, if I'm solving this, 7P 1 minus P equals 6P plus 1 greater than 3. So P should be greater than 1/3. So if there is an interval of P which is satisfying those two inequalities, that implies that this strategy will be strictly dominated. But you can see that there is no interval, like P greater than 1/3, less than 1/4. Ta-da! So what it means, even though I'm mixing those two strategies, no matter what, there is no P or interval of P which can strictly dominating G, right? And in the previous slide, I argued that in a finitely two-player set, strictly dominated strategies are the never best response strategies. But here, it's not. What it means, G should be a member of B1. This part, I think you need to review again after uploading that recorded class again, okay? So, usually I'm going to do more than 2 hours, more than that, but I try to finish a little earlier because if I'm doing a little more, probably it will be a little mess for you. But still, I just introduced the two concepts, never best response and strictly dominated strategy, right? Sometimes we can find an equilibrium or prediction with using just two concepts, but sometimes not. Look at this. I mean, this is the first game I introduced here. Can you find any strictly dominated strategy here or never best response? Nope, right? Sometimes even though we used these two concepts, we cannot find any prediction. Prediction is that one of the outcome will be happened. That's it. So it's not persuasive or any meaning, no informative. So we need more, right? We will do in the next class time. I'm going to finish here a little earlier, but so we are going to upload this lecture. The reason why I'm finishing a little earlier, you need to fully understand what I was doing today. Otherwise, you cannot take any step further in the next class time. Okay? So until now, you should rewatch what I was doing and starting again to fully understand. Now I'm going to give you an exercise about what we were doing, right, at ULMS. Probably you should be familiar with dealing with this ULMS stuff. Okay? Any question? No? Okay. Then we'll stop here.